Okay, this was actually such an easy problem. People thought it was a trick, and it actually was pretty low scoring, especially A and B, even though they're really easy questions. You should recognize logistic differential equation, logistic growth. We know the graph of that looks like that, where you have that carrying capacity up and down. And remember, you could have a top part to that as well. It's also going to reach the carrying capacity. That's if you started with too much in the population, it will die out to hit that carrying capacity. We know right there is where the slope is steepest. So that's where we're going to have the highest growth. So let's go ahead and start. If P of 0 is 3, what is the limit of P of t? Well, remember the limit of P of t is simply the carrying capacity. But I need to rearrange that to see the carrying capacity a little bit better. So I'm going to pull out 1/12. So if I pull out 1/12, I get P over 60. 1 divided by 1/12 is 12 minus P. So right there we see our M is 12. So the limit as t goes to infinity of P of t is 12. Now this is for if P of 0 is 3, right? So if we're at 3, it's going to go to hit 12. Okay, so there's one answer. Now, if P of 0 is 20, meaning we're above that carrying capacity, that limit's still going to reach that carrying capacity. Limit as t goes to infinity, P of t is still 12. So people thought this was a trick question. They're just making sure you know that even if you're above or below, you're still going to reach that carrying capacity. Either your population is going to grow until you hit it, or it's going to decline until you hit it. Either way, you're going to reach that M value. 2 points for that one for each. Part B, for what value of P is the population growing the fastest? Well, again, 1 point here. A lot of people didn't necessarily get it because they thought it was a trick. We found that the carrying capacity was 12, and we know that at that halfway point, okay, that's when it's going to, so when P is 6, that's when it's going to grow the fastest. 1 point. Okay, part C, a different population model for Y satisfies the separable differential equation. Find Y of t if Y of 0 is 3. So we're just using separation of variables. Remember, this is your Y, even though these are capital. I don't know why they did that. So I'm going to divide by that 1 over Y dy. And then I'm going to go ahead and distribute that. 1/5 minus t over 60 dt. I'm going to integrate. That'll give me natural log, absolute value of y. Here I get 1/5 t minus, let's see, t squared over 120 plus c. Don't forget your constant. E to the. So it'll give me y. I'm going to go ahead and separate that e to the c as c. E to the 1/5 t minus t squared over 120. Now I have my initial condition, y of 0 is 3. So I plug that in. So I get 0, so I'll just get e. E to the 0 is 1, so I just get c is 3. So plug it back in, y is 3e to the 1/5 t minus t squared over 120. That will earn you 5 points. And I think it's a pretty easy separation of variable one. Okay, part D. This is where you have to be careful. It's only worth 1 point, but it's all or nothing. Based on the y of t that you found in part C, find the limit as t goes to infinity. So if I take the limit, this is my y of t, of 3e to the 1/5 t minus t squared over 120 as t goes to infinity. Be careful here. Yes, going to infinity, but this one's going to grow faster. Okay, so this top is actually going to be a negative value, which puts that in the denominator. So you're actually going to have 3 over e to the negative, or it's going to be in the denominator then because it's a negative number. So the denominator is going to grow faster. We're going to get 0. A lot of people said infinity on that one. They didn't think as to which one will grow faster.